right, in this video I want to go over just the similarities and differences between fission and fusion. So we'll start with the main one. They are both nuclear processes. And what we mean by that is just very simply involving the nucleus of the atom. That will take us to our first big difference then. By definition, fission is the splitting of the nucleus. So you literally take the nucleus and you split it into roughly halves. It won't be exactly half, but roughly. And then fusion is combining nuclei to make bigger ones, like putting Legos together in a way. So another similarity that they have is that they are both very energetic. But not the same. So fusion is actually a little bit more. It releases more energy. And we could complicate that by saying, per pound or whatever, but let's get the main idea. On a bang for your buck comparison, fusion releases more energy than fission. Now, what elements do this? Well, for fission reactions, if you're going to split them in half, or roughly half, you need to have large atoms. So at the bottom of the periodic table. Whereas fusion is going to be restricted to the smallest atoms. And that's because if you're going to fuse something, you've got to bring two nuclei together. Then you're bringing a bunch of positive charges, or even one positive charge, in closer to a lot of positive charges. And so there's quite a bit of repulsion to overcome. So it just becomes very difficult to fuse the larger you get. Now, with that being said, it is not impossible. We've even seen the video of how they made element 114, and that was by getting calcium to fuse to plutonium. So it is possible. It just becomes very energetic. In nature, fusion can only occur in the stars. That's the only way you can get enough energy to do that. So let's actually put that. Fusion is natural. It does occur in nature, but only in the core of stars, such as the sun. This is the process, this is the fuel that makes the sun burn. It's not really a chemical, it's not burning, the sun's not burning. It is merely a nuclear reaction and will generate a lot of heat. It's more of a physical process up there than it is a chemical process. So what about fission? Is it natural? And the answer is no. So fission is a man-made process. It's not unheard of, I guess, that fission could occur in nature. If you had, for example, a random atom of uranium-235 sitting in nature, that a neutron wouldn't hit that thing and it would split. But I mean, you're talking a rare occurrence compared to all the atoms on the Earth at any one time. It's so rare that you wouldn't even really mention it. So how do we use these processes? Well, fission is more useful to us currently. This is what we have in nuclear reactors and in the atom bomb. So your early nuclear weapons were fission weapons. Fusion currently doesn't have any uses. We haven't been able to make fusion nuclear reactors. Not yet. They're working on it. So right now, fusion's really only use is in the hydrogen bomb. The hydrogen bomb is a bit of a combination you have a nuclear atom, like a fission bomb, that sets off a fusion reaction, and that makes it more deadly. So I guess that we could put that as something to have in similarities, that both can be used in weapons. And hopefully soon they'll both be used in nuclear power. And we will put there in parentheses, soon. More about that in class. And then I guess another thing I can think of for the difference, fission leaves behind waste that is radioactive. So you have to do something with the what's left over, because it's radioactive and will be for virtually forever. Whereas fusion leaves behind safe products and doesn't leave behind anything that's radioactive that has to be disposed of. So all in all, fusion seems to be a little bit better as far as getting some use out of it, but it is a more difficult process than fission. So why don't we just put that? Difficult, and we can even put down here less difficult. Why not? So fusion is kind of what we're striving to in the technological world, whereas fission is a bit of a relic of the 20th century technology. It's very important and very cutting edge when it came, and we still use it, but its time is coming near the end, such as the traditional use for the telephone met its end. So we will talk more about fission and fusion and the nuclear reactors and how they're used in the upcoming class, but I just wanted you to get these notes at a more leisurely pace. See you in class.